In this video, we will cover the basic operation of the LISST-SL2 instrument and software. The LISST-SL2 is a second-generation streamlined instrument designed for measuring particle size and concentration in rivers. This video will walk you through setting up the instrument, collecting a background, deploying the instrument, recording data, and performing simple post-processing. You will need the following items to get started: an SL2 sensor, a computer or laptop, a topside box, which contains the battery used to power the sensor, a topside box USB cable, a B-reel, and a cable for connecting the B-reel to the topside box. We also provide a cable for a direct connection between the topside box and the sensor. This can be used when operating the instrument in the lab, when the B-reel is not necessary. Plug the computer and sensor cables into the side panel on the topside box. Connect the USB cable to your computer. If using the B-reel, connect the power and ground connectors on the topside cable to the B-reel terminals. Plug in the end of the B-reel cable to the connector on the top of the sensor. If you are not using the B-reel, you can directly connect the sensor and topside box using the provided cable. The power button on the topside box is located on the side panel. This will also turn on the power to the SL2 sensor. Now that the instrument is set up, we can launch the LISST-SL2 software. Shown here is the home page of the software. In this video, we will walk through each of the main software functions, which are collecting a new background, collecting data during a deployment, calculating depth averages from previously collected data, and instrument cleaning. A clean water background must be collected prior to deploying the instrument. This can be done in the lab ahead of time or on-site prior to deploying the instrument. For the best data quality, the background measurement should be collected within a few hours of your planned deployment. To collect a clean water background, you will need to have the instrument powered on and connected to a computer. You will also need tubing and connectors to connect the SL2 inlet and outlet, a 0.2 micron filter, and at least a half-liter container of particle and bubble-free water. If you don't have a source of clean water, bottled water will often work well. In this example, we will use the materials provided with the SL2 to set up a recirculating loop. Connect the tubing to the inlet of the SL2 using a push-to-connect fitting. Connect the other end of the tubing to the push-to-connect fitting at the base of the clean water container. Push the specially made fitting into the outlet of the SL2 and use the hole at the top of the clean water container to hold the other end of the tubing inside the container. Fill the container with clean water. Lift the clean water container above the sensor to prime the pump with water. You should see water rise up the tube connected to the SL2 outlet. This indicates the pump is primed with water. To keep the pump primed, set the clean water container on a raised surface above the sensor. Next, connect the inline filter to the outlet. This completes the recirculating loop. In the LISST-SL2 software, select Collect New Background from the home page. You will be asked to connect to the instrument. If you followed the previous instructions about setting up the instrument, you can press the Connect button and the software will automatically connect to the instrument. Press the Next button. It will display a picture showing the recirculating loop connected to the sensor. Since we have already set up the recirculating loop, we can press the button Start New Background Collection Sequence. The pump inside the sensor will turn on, and water will begin to flow. The software will start to analyze the data coming from the sensor. It will calculate an instrument stability parameter approximately every 30 seconds. This parameter is used to determine when light scattering inside the instrument has become stable and background collection should proceed. Once the instrument stability parameter is below 2 for 3 consecutive measurements, a background will be automatically collected. A large temperature difference between the background water and the instrument or dirty water will increase the amount of time required for stabilization. Once a background has been collected, the software will run automated quality control checks on the newly acquired background. If the background passes the quality control checks, it will be indicated on the screen. If the background fails the quality control checks, you will be provided with the cause of the failure and with additional information on how to improve the background. To save the background, press the Accept and Save Background button. The background will be saved on board the instrument. The software and sensor can now be turned off. The background will remain saved on board the instrument and can be used next time the instrument is deployed. Before you begin your data collection, you have the option of using units of meters or feet. On the home page, select the gear icon in the lower right. Here you may choose meters or feet and set the default depth average bins. The depth average bins are part of post-processing and is covered later in this tutorial. In this example, we will choose meters as our length unit. When deploying the instrument in the field, select Start New Data Collection from the software homepage. You will be asked to connect to the instrument just like when collecting a background. After connecting, a reminder about the clean water background will be displayed. It will show the date and time the background on the instrument was collected. You have the option of using the background or collecting a new one. If you choose to collect a new background, you will be brought to the same background page shown previously. If you choose to use the existing background, you will be brought to the deployment page. When you reach the deployment page, you are directed to lower the instrument into the water. The mechanical equipment needed for deploying the instrument in a river is not covered in this video. The required equipment will depend on the sampling site and the sampling objectives. Once the instrument is submerged, press the Start Pump button. This will start the internal pump and begin the temperature equalization process. The software will begin analyzing the sensor data, similar to when a background was collected. However, the software will be monitoring the instrument temperature and waiting for it to come to equilibrium with the water temperature. The instrument will be ready when the instrument temperature stability falls below 0.2 for 3 consecutive measurements. The amount of time required for temperature stabilization will depend on the initial temperature difference between the instrument and the river water. This page also gives you the option to zero the depth sensor. This can be done at any time while waiting for the temperature to stabilize. You will be notified on the screen once the temperature has stabilized. Then you can press the Next button to continue to the data collection page. On the data collection page, you will be able to view the data coming from the sensor in real time. All the numbers and figures on this page are updated once a second, which is the sampling rate of the SL2. The tabs on the upper left side of the window allow you to switch between different displays. The first is a numerical display that shows the current depth, concentration, velocity, and mean size in large numbers. This view is useful if you are viewing the computer screen from a distance. The next option is a time series view. This view shows a time series of the data collected by the sensor. The bottom plot is a pseudocolor plot that shows the particle size distribution over time. The color scale shows the concentration in each size bin. The next view shows the depth profile. These plots show the same parameters as the time series view, only they are plotted as a function of depth instead of time. On any of these plots, you can hold the mouse button down to see the numerical values of any data point. The last tab contains the plot controls. This tab allows you to manually adjust the scales of the plots, clear the plots, or turn off plotting altogether in case you need to conserve computer resources or computer battery life. It is very important to note that just because data is being shown on the screen, it does not mean it is being recorded. To record data, you will need to enter a data file path and base name. The path specifies where the data files should be saved on your computer, and the data file name is the unique name you wish to give your data files. Once you have filled in these fields, you can press the Start Recording Data button to begin logging the data. When the data is being recorded, the number of recorded samples will be displayed in the lower left corner of the screen. You may start and stop logging at any time, with the option of appending new data to a file that has already been started. The software produces two data files, a .rbs file and a .asc file. The RBS file is a binary file that will be of little use to most SL2 users. However, it can be invaluable for instrument troubleshooting or advanced data processing, so we suggest you keep this file with your data, even though it may not be used. The .asc file is a text file that contains all the calibrated data collected by the sensor. See the SL2 user's manual or the headers in the file for a description of the data. Once you have finished data collection, it is important to press the Finish button just before removing the sensor from the water. Pressing the Finish button will turn off the internal pump. The pump should never be allowed to run dry, so it's imperative that this be done before the instrument is lifted out of the water. The final page of the data collection sequence is a reminder to flush the instrument with clean water at the end of each deployment. This can be accomplished by connecting the intake of the sensor to a container of clean water and running the pump at high speed. This will help flush out any remaining particles or debris. You may also wish to clean the instrument optics at this time. Instructions on how to clean the optical windows is covered in a separate video. This concludes the data collection sequence. The cleaning page can also be accessed directly from the home page by clicking the Clean Instrument button. This will bring you back to the same cleaning page that we saw at the end of the data collection sequence. Once you have collected a data file through the data collection sequence, you can quickly bin the data by depth using the SL2 software. Start by clicking on the Calculate Depth Averages button from the home page. Select the .asc file you would like to process. The Depth Averages screen will open and bin the data using the default depth bins. You can add, remove, and modify depth bins using the table on the left. The center depth is the center of the depth bin, and the depth window sets the size of the depth bin. For example, a center depth of 5 meters and a depth window of 1 meter would bin all the data between 4 and 6 meters. The depth average plots will be updated as you manipulate the table. The third column of the table displays how many data points are in each depth bin. New depth bins can be added by typing in a new center depth and depth window in the blank row at the bottom. Depth bins can be deleted by selecting a cell in the row you'd like to delete and pressing the Delete button on the keyboard. The data set can also be constrained by time. Below the depth time series plot, use the sliders to exclude data based on time. For example, you can use this feature to only look at data from the downcast or upcast. Similar to the data collection page, there are tabs that allow you to switch between different views. The first is the depth average view, which shows box and whisker plots for concentration, mean size, velocity, and temperature for each of your depth selections. In the box and whisker plots, the solid vertical black line is the mean value. The bounds of the box are plus and minus the standard deviation, and the whiskers show the minimum and maximum values in the depth bin. Again, you can click and hold to see the numerical values for each of these parameters. The Particle Size Distribution tab shows the mean particle size distribution for each of your depth bin selections. Lastly, the Raw Data tab simply shows a depth profile of the raw data in the file without any binning. The bin data can be saved in a summary file by pressing the Save Summary File button. This will save a .txt file containing the average data. See the user's manual or the headers in the file for a description of the data saved in the file. This concludes the tutorial on the operation of the LISST-SL2. For additional information, please visit our website or contact us at info@sequoiasci.com.